Thanks, Greg, and good afternoon, everybody. Yeah, so today going to tell you a bit about our CalfWatch project. We were wanting to get a bit of a sexy name for it, and so CalfWatch is what we came up with. We were sort of thinking about baby monitors for calves or something like that, but in the end we went for a sort of like a Baywatch, CalfWatch. Anyway, hopefully that'll become a bit more apparent as we get into it. First off, though, just to set the scene, calf loss is a major problem in Northern Australia. So there was a publication that estimated the costs of it at 54 million annually just for the loss that occurred in the first 2 weeks of life, and that doesn't include the cost of calves that die out outside of that period. So that's a big cost to the industry every year. And then I've got on the screen there some figures from the Cash Cow project, and this was data that was recorded on stations, commercial properties across the north of Australia. And you can see there the Northern Forest, which is sort of where we are here in Katherine. The median calf loss rate was 13.5%. The 75th percentile is 19.2%, and you've got to remember there's still another 25% of properties that are worse than that. So a big problem on a lot of places. And then comparing that to what happens in the Southern Forest, which is basically southeast Queensland, the figures are much lower. And I guess what that shows us is that there's a lot of scope there for improvement in the north. The other thing about those figures is that we're really underestimating the problem still, because when we calculate calf losses, we use records from preg testing to weaning. So if a cow is tested pregnant 1 year and then comes in the next year and she's dry and not wet, we know that she's lost her calf. But if the cow doesn't come in, if it's died calving, then it doesn't get included. So those figures are probably an underestimate. And calf loss is even a bigger problem than that. Now these are some figures from a heifer research project that I led a while ago now in the Northern Territory on commercial properties, where we went around and did on-property recording. And you can see there the average calf loss in first calving heifers was 22%. So that's a big loss. And you can see those figures in red, where it's up over 30%. So really, down here, up close to 40%, really big losses. And they tended to be on the big mobs that graze in big paddocks. And that got us sort of wondering about paddock size and distance from water. If heifers are calving a long way from water, leaving their calf to go and have a drink, does that create a lot of problems with calf loss? And if so, it probably really changes the economics on reducing paddock size, not only to get more even grazing, but also to get benefits in reducing calf loss. But the point is, at the moment, we don't know. So that's where the focus on calf loss at the moment is really finding out these causes. So in the past, calf loss is obviously not a new thing. In the past, they used traditional methods, observations, people going around probably in the early days on horses and then motorbikes or vehicles, and observing cows out there in paddocks calving, and generally they'd have to be in a fairly small paddock to be able to find them to do that. And the other thing is that when you are driving around and watching a cow calve, or especially a first calving heifer, it alters their behaviour and they get a bit flighty and run off, and that changes their behaviour and can even contribute to the problem and cause mismothering. So the other issue with calf loss studies is that it's been very difficult to find the dead calves, the carcasses, so that you can conduct a post-mortem to determine the cause of death, and that's got to happen very quickly after the death. You can't come find a carcass that's a couple of days old and then do a post-mortem that's going to tell you much. So even if you could find them, that'd be too late. But the problem is in big paddocks that you just don't see them. They happen out there in the bush somewhere, and you don't see these carcasses all scattered around the water trough when you go to fill up the supplement or check the water. There's a lot of calf loss that doesn't ever get seen. So if we could remotely monitor calving and get these observations, collect data that previously wasn't possible, it would be a real game changer in the area of studying calf loss and greatly increase our knowledge and help us to identify solutions to reduce it. And that's what this project is all about. So our aim was to develop a method to remotely monitor calving and find dead calves, and then to use it to find ways to reduce calf loss. In other words, to find out where and when calves are born, and then where, when, and why they die. So that's a nutshell. So this project is as much, or probably more so even, about developing the technology to remotely monitor calving as it is about actually using it then to identify the reasons for calf loss and coming up with ways of solving it. And so at this stage, most of our efforts have been on developing this technology, but we do have a year's worth of observations that I'll go through later in the presentation. So as far as how we did this, there's a group of researchers at the University of Florida, led by Raoul Boughton, who you can see there, and he's actually an Australian, but has lived in Florida for quite some time, and is actually a wildlife ecologist. So a lot of history in tracking animals and studying animals, and he, the ranchers in Florida identified calf loss as being a big problem for them, as our producers here have, and they wanted it addressed over there, and Raoul was leading a project to do that. So they, their method was they adapted some birth sensors. Now these birth sensors are actually produced by a French company called Madria, and they're adapted for a barn system and sold in North America by a company called JMB. And the Florida team purchased these sensors from them and then used them in their trial. So the sensors really are designed for dairy and feedlots, which is you know, very different to our purposes. And so they've required a bit of adaptation to use them in a wider area. And so we worked with Raoul and his team to come up with ways where we could use these things in much bigger areas than what they're doing over there. So the system uses these birth sensors. You can see them on the table there. They've got these little spider legs, we call them. You sort of scrunch them up in your hand and put them inside a pipe applicator that you might see later in the presentation to insert them into the vagina of pregnant cows about, well, up to 4 months before they calve. And then when the cows calve, they push these sensors out. The calf coming out pushes it out onto the ground, and the rapid change in temperature causes them to start emitting a UHF signal that is received by antennas mounted on towers in a low power wireless area network. And those signals are then transferred by a gateway through the internet to the servers owned by JMB. And then what happens from there is a calving alert gets sent and is also immediately viewable on a website. So basically we end up with an alert on our phone to tell us that cow number such and such has calved. So the first step was to, once we came up with ways of increasing the area that we could cover with these things, was to do a pilot study at Katherine Research Station and to build towers and set this gear up. And I just want to acknowledge the great work of the manager at KRS, Jack Wheeler, and his staff in designing and constructing these towers. They really were a fantastic piece of bush engineering. You can see there how we've or how they got the forks under the pole to lift it up and drive the Toyota under it, and then come around the other side and push it up against a bit of bore casing that they've pounded into the ground. So it all worked really well, and they did a great job at building low-cost towers that were very, very functional. So each of these towers has a read range radius of about 1.8 kilometres in 360 degrees from the tower. You can see a fully set up one there on the right of the screen with the antennas up the top. They're equipped with a power supply, so we've got 3 solar panels and 2 batteries and a solar regulator. There's an Ethernet gateway that is attached to the UHF antenna that receives the signals from the expelled sensors, and then it sends them via a rugged modem and a Yagi antenna, because we've got very poor or basically no mobile phone reception in a lot of the places where these cows are calving, and so that's the way we've got around that. And just to give you an idea of cost, the birthing sensors cost in US dollars $177 each, and that includes the web services to monitor them and send us the text messages. And then the towers, all the steel, everything, panels, everything was about $9,500 Australian. So initially, in our pilot study, we had a few teething problems. One of the antennas that actually met all the specifications actually was causing problems, which surprised us that an antenna would do that. But eventually, we worked out what was going on and swapped antennas and got around that. And basically, it worked pretty well. Now, in theory, these birthing sensors should have enough battery life to be used 2 or 3 times. But the thing is, you've got to be able to find them to reuse them, and that proved to be an issue for us. In our pilot study, we just couldn't find them. So you can see here, probably gives you a good clue as to why. On the left there is when we went over to Florida and learned how to use the system over there. You can see how much easier it would be to find an expelled sensor there, where you can even see my shoes compared to the ground in Katherine, where you've got grass up over your knees and trees, and we just basically we just could not find these sensors, even in quite small paddocks. We couldn't find the expelled sensors. So that was what we got out of the pilot study, and it reinforced that we needed a way of finding these birth sites, especially when we were going to scale it up to bigger paddocks. Now, originally, before we even went into this project, in our meetings with J&B, they told us that they planned to put GPS chips in the birthing sensors so that we would get the GPS coordinates of where they were expelled, and obviously that would have solved all of our problems. But unfortunately, once we were into it, they changed their mind and decided that there wasn't enough market requesting that sort of a feature for them to bother with the expense. As I said, most people using them in America are in dairy, and so they don't need to find them. They can just go and look for them. So our next way of trying to find these things was to put a GPS tracker on the cow so that we could know where she was when we got the calving alert. And that was the avenue that we went down. So that wasn't actually as simple as it sounds. I was fairly new to GPS tracking collars on cows at that point, and I thought that should be fairly simple. It's true that you can go out and get satellite GPS trackers and put them on cows that will tell you where they are quite frequently, and you can get that data back in real time. But at that time, they were about $2,000 each, and our budget wasn't that big. We wanted them for about $300 each. So went searching for GPS tracking collar manufacturers in Australia, and basically the features that we wanted, which were to ping each collar every 15 minutes. And when it comes to GPS tracking collars, a lot of the devil is in the detail. So there are collars out there that ping. When I say ping, that means pinpoint the location of the cow 4 times a day, and obviously that's not good enough if we want to know where she is when she's calving, because they can walk a long way in 4 or 6 hours. So we wanted it every 15 minutes. We needed the batteries to last at least 4 months, and we needed to get this GPS location data in real time. So actually when it was happening, and that ruled out collars where they saved power by storing the data on board, and then you access it later on when you take the collar off, or other ones where it stores it on board, and then when the animals walk past an antenna on the way to the water trough, it downloads the data. That's obviously not going to help us either. So we needed the data in real time, and we had those budgetary requirements of $300 per collar. And at the time, the only company that could meet those requirements in the time frame that we had was a company called Smart Paddock, which is an Australian company based in Victoria. So you can see one of the collars on a cow there. That was the first prototype that we used, and then you can see here, this is the website where that we used to find a cow. So we would, when we got the calving alert, we'd type her number in over here, and that would give you her current location, and then this screen expands and you could see where she'd been for the last 15 minutes, and you could set the period for either 12 hours, 24 hours, or several days. There is a bit of a heat map and a green dot that shows where she is. And so we would use this information to pinpoint where the cow was at the time when we got the birth sensor alert that she'd started calving. So that all worked extremely well while the birth sensors were working. Not the birth sensors, sorry, while the GPS collars were working, and I'll go into that a bit later. But this is an aerial photo here of the paddock that we were working in. So this was the year after the pilot study. We scaled it up and we put birth sensors and tracking collars on 200 cows in a big paddock, and this is on Mambaloo, which is a property at that point was owned by CPC and not all that far out of Katherine, and we leased a couple of paddocks there. And so you can get a bit of a feel for the size. It's 6 kilometres along that fence line, 2,215 hectares, and we needed 4 towers to cover that area adequately. So that's the way we set that up for the when we scaled it up to do the proper study. So in August, we put the birth sensors in. You can see some of the tool that I was using to put them in, and we put the GPS collars on the cows on 200 cows, and from what Raoul tells me, that was a world first at that time to have that many GPS tracking collars on cows in that sort of scale. So that was pretty good for a little project in Katherine. And yeah, I've covered that. So basically, the technology worked very well. We received alerts from 85% of birth sensors that were expelled, and if the GPS tracking collar was working at that time, we were able to locate the cows and go out and find them and collect the observations that we need. And you can see a calf that's just been born there. And it was quite funny actually to, these cows would be, some of them, several kilometres out from water under a tree in the long grass, and you'd turn up to take your observations. And I was thinking, these cows must be thinking, now how the heck did he find me? But of course, it's easy when you've got GPS coordinates. But even just getting around and doing all these observations in the paddock, it's a pretty rough paddock, lots of rocks and trees and anthills and logs under the grass. So took a bit of a toll on tyres and that sort of thing. But it did allow us to observe a lot more cows calving in a big paddock than would have been possible without this technology. We just would not have found them, and we were able to do it with minimal disturbance of them. However, we did have some issues with the GPS tracker reliability, and if the tracker wasn't working, it was pretty much impossible to find the cows after we'd received an alert, and we had to wait until they came into the water trough to get the observation. So the Smart Paddock have gone back. They've had a look at the collars and identified the reasons for the failures. A lot of it was just due to the higher temperatures that we were operating in up here. I'll spell that out a bit more in a minute, but basically they were causing the LoRaWAN antenna circuitry designed to scramble the outboard signal. And the other thing is that the heating and cooling seemed to be creating a pressure differential, and there was some air leakage and moisture getting in, even though the enclosures that they'd used were what they call IP rated, which I've subsequently found means ingress protection. But anyway, the short story is that they've used the information from this study to come up with a new and improved model that will overcome those problems. and that we plan to use in the next calving season. You can see what it will mostly look like on the right there. It will have a much heavier weight on the bottom to keep the GPS tracker up near the top. Now, the other thing is that the GPS tracking collars contained accelerometers, and it is our hope that we might be able to use accelerometer data to identify the time of calving from characteristic changes in movement patterns. And you can see here the data from one of the cows, and it's very plain to see there when she's calved, and that's verified by when we got the birth sensor alert. So you can see obviously her movement patterns leading up to that point are very different for a few days there, and then they change as she starts walking around again. But so if we could do this, this would be an excellent advance where you wouldn't need to mess around with the birth sensors. It's less invasive, removes the need for one set of technology. However, there would be problems in getting that data. If we're wanting to use it to get calf birth observations, there would be a bit of a lag. You know, it'd need to go long enough so this you didn't get a signal right here, but you need a big enough gap to determine, yes, that actually is a birth event. So that'd be very good for where, you know, say people are wanting to identify birth date, perhaps for breed plan records or studs where they need to know date of birth, in which case, you know, perhaps they could get that just from a collar. And having the birth sensor to verify it we're getting some great data for that. So we're hoping to develop up the algorithms for that. And I know there's a number of other companies working on a similar sort of thing, and certainly not averse to pooling information and working on that together. So that's that. So despite these GPS issues, we were still able to get observation on most cows within 2 days of calving, and this was because of the hot weather. I guess also for people that are not familiar with Northern Territory or North Queensland, Northern WA, what generally happens in big paddocks is that in the hot weather, the cattle congregate around the water during the heat of the day, and that gets really grazed out. So you can see there's not much grass around, next to none, and so they'll sit around there during the heat of the day, and then they'll walk off in the late afternoon and graze through the night. And so we during the period of calving, October, November, December, it was up around 40 degrees most days. We didn't get any rain until early December. And because of that, pretty much all the cows were coming into the water every day. If they did calve, they might have stayed out for a day or so, but they would come in, and then we could get the calving observations then on whether they've already lost their calf or they've got a calf with them and it's looking healthy, and that sort of thing. So in that way, it worked for us in getting our observations, but there are some other issues which we'll look at as well. So as I said, we got alerts on 85% of the birth sensors around calving, and the ones that we didn't get alerts correctly for, 4 of them were, so 4 out of 200 were expelled early, so more than a month before calving. 2 alerts we got after the cow had been seen with the calf, so too late, and the rest we weren't able to determine because basically we couldn't find them. They're really ones where the GPS tracker wasn't working on cows, so we couldn't find the sensor, and we just saw a cow and observed her to have a calf, and took our observations. And so we don't really know what the problem is there. It could have been a malfunction, or it could have been that they were the position they dropped in the paddock may have been something blocking them. We're not really sure. With better GPS trackers, we should be able to get to the bottom of that a bit more. So we were able to get enough data or observations on cows to determine the outcome of 208 pregnancies. So we actually had some more cows in the paddock that weren't tagged or had had the birth sensors in, and we just recorded them when they came into the water. Anyway, overall, the calf loss rate in mature cows was about 17%, and that's at the high end of the normal range for mature cows. I'll go into the reasons a bit later, but we saw that the calf loss, we did have about 50 odd first calving heifers, and their calf loss was very high, so 36%, which is very high. However, there are probably some major reasons for that. One being that we trucked them from an improved pasture area to this harsher location while they were pregnant, and we know that's not good for them. We did want some animals there where we were going to get calf losses just to get the to test up our technology and our systems, and so that's why we did that. But it wasn't, it didn't work out well for a lot of those little fetuses. So looking at the reasons in the mature cows, the average was about 7% or 6% higher than the average. We've been leasing these paddocks for quite a long period of time, and over the last 4 years, the average calf loss was 10.7%. This year we got 16.8%, which was quite a bit higher. And when we look at why, it's likely to be due to the cumulative effect of several different factors, as all calf loss is a result of, calf loss rates are a result of several factors. I think the late start to the wet season, the very hot, dry conditions would have played a role, and the wet season was a very poor one, so it was the worst in 50 years in Katherine, and that would have contributed as well. It's possible, even though we tried to disturb the cows as little as possible, if they looked fidgety when we drove up to get observations, we'd back off and use binoculars. But it is possible that we may have disturbed them and altered their behaviour a little. There were also wild dogs present in the camera. You can see a shot there from a trail camera that we had set up, and you can see on the right-hand side, we actually turned up at just the right time to see a pack of dogs chasing a calf, and he would flopped on the ground there exhausted. He did get up after that, but subsequently died. But when we looked at our records, this calf had previously been noted to be sick and weak and wobbly on his feet, and that's, I guess, why the dogs have identified it to chase. When at the weaning muster, when we looked at evidence of dog attack on the calves, so from ripped up ears and scars and things like that, the evidence of dog attack was actually quite low. So about 2.5% of calves had evidence of dog attack. And from work that my colleague Kieran McCosker and Will Dobby have done on commercial properties, that's actually below the NT average of 6.2%. So I don't think it was a major problem. Also, during the course of the project, we set up a portable yard in the paddock and mustered a group of cows and calves to tag 50 calves with VHF tracking tags. So you can see one of these tags here on the right. It was a technology that we wanted to use to monitor calves. We would have got an alert to say when that calf had died or stopped moving, but we just found it was too difficult to safely catch calves due to all the rocks and logs and long grass and cows that tried to eat you. And in the end, we decided we'd run the calves in, put some tags in their ears, and test the technology that way. Now, that mustering cows and newborn calves is not a good idea if you want to minimise calf loss. We've done it for research purposes, and that may have also contributed calf loss, even though they were in a portable yard in their paddock and they were only in it for a couple of hours, but could have contributed. So when we look at the causes of calf loss, we've got here, this is in the mature cows, so a total of 17%. We've still got the majority of causes being unknown, and that's because the GPS trackers weren't working on those animals so that we could have identified what happened there. And in future, we'd like to, well, we will see that reduce because with better GPS tracking, we'll be able to find them. Dystocia in mature Brahman cows is very low, but it was higher in the first calving heifers. Bottle teats was a major problem in the cows, and I'll look at that in a sec. And then there was a couple of these other reasons we see here with neonatal septicemia and bacterial infection through the umbilical cord in 1 or 2 cases, and that was from post-mortem results. So here's a cow with bottle teats. What we found, because we were getting the alerts and we were seeing these cows at the point when they calved, we were seeing these cows with bottle teats, and we were recording, yes, she had bottle teats. Later on, we recorded that her calf was no longer around, it had died. And then several weeks later, when we looked at her udder, it looked completely normal. So these are cows that would go undetected in a herd if you're only mustering twice a year and assessing their udders at a muster several months after she's calved. It had shriveled right back up and didn't look like she had bottle teats. So there would be a lot of cows out there in northern herds which have problems with bottle teats and kill calves and are going undetected. So that is something that we've been able to find out because we're getting these alerts right at calving and able to take those observations. As with previous studies, we're still getting a lot of unknown causes, but we should be able to minimise that with better GPS tracking. The dots on this map are where actual calving locations, and the green ones are from mature cows, and the red ones are from first calving heifers. So we saw there that they really did calve all over the paddock, especially mature cows. The first calving heifers calved a lot closer to the water. So on average, they calved 1.2 kilometres from water compared to cows, which almost calved 3 kilometres from water on average. There were a few hot spots where numerous calves were born, but they were really scattered throughout the paddock. And that really shows that you know, even though there was only this one water point, which was right up here in the corner, the blue thing there, that cows were still walking away either to find more private places to calve, or when they were grazing a long way away, they were calving a long way. And this is you know, 5 kilometres from water this calf has been born. So it's a fair old walk in for a little calf on a hot day. The GPS data showed that the cows were walking between 8 and 11 kilometres per day. And as I said, some cows were calving more than 5 k's from the water point. And this is, you know, I guess for some people it's a large paddock, but in the scheme of the Northern Territory and especially on the Barkly, that's a fairly small paddock. So, you know, heifers and cows will be having to walk longer distances than that in some of these big paddocks. Other interesting data here was we found that 71% of the birth sensors were expelled during daylight hours, and the peak was here in the middle of the day between 12 and 3. That was quite interesting. Now, went looking through the literature and found that studies in the USA found that when they feed in lot feeding or barn feeding operations, if they feed at night, then they get most of the calves born during the day, and that is easier for the workers that are around pulling calves and assisting in birthing as they do over there. And so that's why they would feed at night, to make the labour easier. So we weren't feeding, but because there was no grass around the water points, it meant that our cows were feeding at night, and that probably explains why we saw a similar pattern in births. And I guess that leads on to, or gives evidence to looking at, you know, is there any benefit of having shade around water points? There's a photo there from the Barkly tableland of a couple of little calves trying to find the tiny little bit of shade that is available, and so is there, you know, benefit in doing research into providing shade in big paddocks where there is no natural shade? And my colleague Kieran McCosker is actually looking at that at the moment. So where to from here? Just to wind this up, we're repeating the study over the next calving season with the improved GPS tracking collars. Hopefully that should allow us to find all the cows, and so there'll be a lot less unknowns, and refining the technology and scaling then up, and hopefully using it to identify causes of calf loss. And just some acknowledgements there to all the people that had helped. Really was a team effort. You can see Raoul here came over and helped us when we were inserting, and then we had especially Elle Fordyce and Mel Wooderson, who did, there's Elle there, did the majority of the calf checks and responding to calving alerts on weekends and that sort of thing. And we had some help there from Jane and Gretel and a couple of Brazilian students that were with us, and also for my colleague Kieran with his expertise with technology, and one of our local firms here in Katherine in supplying and helping us install the equipment. and of course MLA for funding the project. So I'll draw it to a close there and hand back to Greg.